This is the second lesson of the week for ChemCom about Bohr models and ions. Cohort A, you're doing this on Wednesday, and Cohort B and e-learners, this should be done on Thursday. So make sure if you are in Cohort A today, you complete the Bohr model and ions and the exit ticket. Cohort B, please complete the atomic spectra lab, and then these are opposite for you tomorrow. You should also receive a worksheet titled 2020 Atomic Structure Project for ChemCom. This is what you are doing on Friday. I will give you more information about that, but just make sure you get the sheet for Friday. Go ahead and take out your periodic table. You will need it often today. We will be referencing it, and I will have you write a few things down on your periodic table. So go ahead and take that out, and let's get started by reviewing. So reviewing Bohr models, let's draw the Bohr model for lithium-7. If you look on the periodic table, lithium has an atomic number of 3, so we will put 3 protons in the nucleus and 4 neutrons because the mass is 7. How many electrons should we draw? If we have 3 protons, we should be drawing 3 electrons. So we go 1, 2, 3, right? 2 on the first ring. The first ring is full with 2, and then 1 on the second ring. How many valence electrons does it have? Look on the outermost ring. I see 1 valence electron. So lithium has 1 valence electron. One more review problem, sodium. Find sodium on the periodic table. You will see its atomic number is 11. So that's 11 protons. It will also have 11 electrons. The neutrons, though, from the mass of 23, 11 plus 12 neutrons is 23. So let's place all 11 electrons, 1, 2 on the first ring, 3, 4, 5, 6, 7, and 8 on the second ring. And then the 11th electron would go on the third ring. How many valence electrons does sodium-23 have? Look on the outermost ring, and there's only 1 as well. So look on the periodic table and find lithium, which had 1, and find sodium, which also has 1. And you will notice that they are on, they're in the same family, the alkali metal family. There is a trend in valence electrons. Notice that hydrogen has 1 valence electron, lithium has 1 valence electron, and sodium has 1 valence electron. We continue to the right there with beryllium and magnesium. If we go to the right, we have 2 valence electrons on beryllium, and there's 2 on magnesium as well. 3 on boron, 3 on aluminum. Hopefully you're starting to notice a pattern. Carbon has 4, silicon also has 4. Nitrogen 5, phosphorus 5, oxygen has 6, sulfur also has 6, fluorine 7, chlorine 7, neon has 8, and argon has 8. So this is a trend in valence electrons. The periodic table could also be said to be arranged based on valence electrons because it's the valence electrons that give each family their unique properties. There's one that I've left off. It's helium over here. Notice helium does not have 8 valence electrons. This is the one exception. Helium has 2. Okay, so make sure you know that helium has 2 valence electrons, but everything else in the noble gases has 8. So without drawing a Bohr model, how many valence electrons are in each of the following elements? So barium, if you find barium on the periodic table, you will see it's an alkaline earth metal, and so it has 2 valence electrons. Go ahead and find iodine. Iodine is a halogen. It's beneath fluorine. Therefore, it has 7 valence electrons. Gallium. Gallium is right beneath boron and aluminum. So it has 3 valence electrons. And polonium, it's on the bottom right. Polonium is beneath oxygen, and so it has 6 valence electrons. So let's talk about something new today, forming ions. How does an atom become an ion? It can either gain or lose electrons, but it's helpful if we draw Bohr models, which we'll get to here in a minute. But an atom will form an ion in such a way as to have a complete valence shell. The noble gases have complete valence shells, and so we could also say that atoms form ions to be like a noble gas. They're not a noble gas, but to be like a noble gas on the far right side. As such, the noble gases do not form as ions. They already have a complete valence shell, so they do not need to gain or lose electrons. So if an atom gains electrons to have a full shell, it would be an anion. That means it would be negative. And if an atom loses electrons to have a full valence shell, it would form a cation, which is positive. Atoms will do whichever is easiest to form an ion. Easiest meaning they can either gain or lose. And if it's easier to gain or easier to lose, that's what it will do to become an ion. So let's look at a Bohr model. So this is lithium, which we've already drawn. So how can lithium end up with a full valence shell? Well, it can either gain 7 electrons to have a full second ring, or it can lose 1 electron to have a full first ring and nothing on the second ring. Which one's easier, gaining 7 or losing 1? Hopefully you say losing 1 electron is easier. So if we lose 1, let's go ahead and if you look on the Bohr model, we can remove that electron. And now we have a full shell. So what's the charge on lithium? Well, now there's 3 protons and only 2 electrons, and so more protons than electrons, so it has a +1 charge. Lithium will always form a +1 charge because it will always lose its 1 valence electron. What about boron? What charge will boron have as an ion? How does it get a full valence shell? It can either gain 5 or lose 3, right? Look on the second ring. It can lose its 3 valence electrons, or it can gain 5 more to have a full second ring. It's easier to lose 3, and so if we remove these 3 electrons, now we have the full valence shell on the first ring. So what is the charge on the boron ion? So there's 5 protons and only 2 electrons, so we have 3 more positives. So those 5 protons and 2 electrons would make a 3+ charge as an ion. 2 more examples. What about fluorine? Fluorine, I've already drawn the Bohr model here. We have 9 protons, 10 neutrons. So there's 9 electrons normally. Fluorine has 7 valence electrons. It's a halogen. So how can it get a full valence shell? What can it do? It can either gain 1 or lose 7. So which is easier, gaining 1 or losing 7? It's much easier to gain 1 electron. So let's add that electron in there. So now you can see the second ring is full. So what's the charge on the fluorine ion? Well, there's 9 protons and 10 electrons. And so with more electrons, it would have a -1 charge as an ion. What about oxygen? How can oxygen get a full valence shell? So we have 8 protons, 8 neutrons, and 8 electrons. So oxygen, hopefully you're starting to think about this, it could either gain 2 or lose 6. If it gains 2 electrons, it would have a full shell on the second ring. If it loses 6, it would have a full shell only on the first ring. But what's easier? It's easier to gain 2 electrons. So let's add those 2 electrons in, and now you can see it has a full shell. But that means it has 10 electrons and only 8 protons. So what's the charge? We have 10 electrons and 8 protons. It's a -2 charge. So hopefully you notice it's all about the valence electron. So here's what I want you to write on your periodic table if you did not already do so. Above hydrogen and above the alkali metals, there's 1 valence electron. Make sure you know this number represents the valence electrons. The alkaline earth metals have 2. We do skip the transition metals, so go ahead and look over at boron. Group 13 has 3, carbon 4, nitrogen family 5, oxygen family 6. The halogens have 7 valence electrons, and the noble gases have 8 valence electrons, with the exception of helium, which has 2. Make sure you put it 2 next to helium, and the rest of the noble gases have 8. But as we've seen with forming ions, it's all about how many valence electrons does it have. Will it lose all of its valence electrons, or will it gain more? And the atoms will do whichever is easiest. So how will an atom in the alkali metal family form an ion? It has 1 valence electron, so it could either gain 7 or lose 1. It's easier to lose 1, so it will form a +1 ion. The alkaline earth metal family has 2 valence electrons, so it could either gain 6 or lose 2. It's easier to lose 2, so it's a +2 ion. Moving over here to the boron, aluminum, gallium family, there are 3 valence electrons, so it can lose 3 or gain 5 to have a full valence shell. It's easier to lose 3, so we have a +3 charge. The carbon silicon family, we are going to skip that because you could imagine it's plus or minus 4. And a little secret, carbon and silicon do not form ions. They participate in covalent bonding, which we'll get to later in the semester. So we skip carbon silicon and jump to nitrogen phosphorus. 5 valence electrons, it's easier to gain 3 electrons. So if we're gaining electrons, it's negative. So -3. Oxygen, sulfur, selenium would gain 2 electrons rather than lose 6. And so it's a -2 charge. And over here, the halogens, 7 valence electrons. So it's a -1 charge. The noble gases do already have a full shell, so they do not form as ions. So you should have this written down on your periodic table. You should know the ion charge that it forms as well as the valence electrons. Without drawing a Bohr model, I want you to state what the ion charge is for each of the following elements. Find strontium. It's on the bottom left side. Strontium is in the alkaline earth metal family, and so it has a +2 charge. Go ahead and find selenium. It's beneath oxygen. So what charge would it have? That is a -2 charge. Find rubidium. It's an alkali metal beneath lithium, so it would have a +1 charge as an ion. And arsenic. Arsenic is beneath nitrogen with 5 valence electrons, so it would gain 3 to have a -3 charge as an ion. All right, so next time, make sure you complete the Atomic Spectra Lab if you have not done so. Check back for more information about the Atom Project on Friday. I will post that information on the page, on the Canvas page. And so now, please complete the Bohr model and ions worksheet, as well as the Bohr model and ion exit ticket. You can email me if you have any questions.